All right, so we're recording, so we're going to talk about geometry. Um, we're going to talk first about something called lines. Um, now it sounds very boring, right? Well, it's not. Lines are great. So geometry is like shapes and stuff, and there's a lot of stuff on this, and I'm pretty sure the ASVAB is going to have a lot on shapes um, and geometry. So we'll go over a lot of stuff tonight. So the first thing is everything is made up in some way of points. Like you can imagine there's a point, like a point on the grid. Um, Now when you get a bunch of points together and they go on forever, it's called a line. That's a weird thing about a line. In math terms, a line is something that goes on forever. Goes on and on. Now, let's say you have a point and a point and a line in between. That is called a segment. This is just like vocab right now, a segment. So like shapes are made out of segments. So like here, oh, that was a very ugly one. Pretend like that worked. Like this triangle has segments making up. And finally, if you have one thing like this with a point on one end and then it goes forever in the other, it's called a ray, just like a ray of sunshine starts in the sun and goes forever.
Okay.
Um, now
Yeah,
I'm
I
going to
think
show you. Yeah, sorry.
I said, yeah, I think I remember all these. Yeah.
Good. Now, when we have two lines and they come together, they're called intersecting lines. And we're going to talk about these in a little bit, like how their angles work. But I want to show you one special one. When they have a little triangle right here, or not a triangle, a little square right there, it means they are perpendicular. Funny big word. And that means they intersect at 90 degrees. So just like hopefully the table you're using is like or desk has a square corner that's 90 degrees. Just like it has that, that's designating that in the shape that it's um, sorry, that it's perpendicular. All right. So let's talk about angles now. We've got several kinds of angles. So these are some important puppies that we have. Angles. Now, what is an angle? It's when two lines or segments meet at a common point. Two common points for rays or segments or lines. So let's say we've got two lines. They meet at this point. We're going to call this an angle. So we've got three kinds of angles. We have and I've got some good news for you all. Someone who is in our ASVAB program, we had an in-person one as well. She started with a 16 on the ASVAB and just got a 36. So she put in the work. It works if you put in the work, and I know a lot of you are putting in the work. Can you all hear me fine? I know my internet's like unstable.
Yeah.
Yeah,
Does
I can hear you.
okay, great, great. All right, so you've got an angle, and you got this point here. This is called a vertex. There's three there are a lot of angles, but let's talk about three main ones. So this is acute. This one, acute, less than 90 degrees. Then we have this angle. Here's the point. There's that. This is called a right angle. It is 90 degrees exactly. Wow, my tutoring group chat is blowing up. Wow. Would you like to temporarily mute this conversation? Mute. Let's see, gotta be. I don't need to do that. Right, exactly 90 degrees. Now there's one more we're going to talk about, an obtuse angle. Obtuse is greater than 90 degrees, less than 180. And there are other angles. There's like the one that's 180, that's just like a line, a straight angle. There's a reflex angle that's greater than 180 but less than 360. And finally, a full angle is 360 degrees. That's not that important. So let's talk about several different kinds of angles. So let's talk about complementary angles. Complementary angles. These angles equal 90 degrees. So let's draw a right angle. If my lines are straight, that'd be nice. And let's say it has two angles in it. One is 45 degrees and the other is 45 degrees. That means they're complementary. They're complements of each other. That means they come up to 180. Sorry, they come up to 90 degrees. So for example, so here's a question for you. Say I have a 50-degree angle. What angle is going to be complementary with that to equal 90 degrees? You can either say it, you can put it in the chat. What angle is going to be complementary to that angle? If it means they both equal 90 degrees. Anyone? Anyone? So two complementary angles equal 90 degrees together. What is the complement of 50? All right, I guess I'll do it. So if we have 90 degrees minus 50 degrees, you get 40 degrees. Let's look at this angle. This is a right angle. You have this angle, which is 1 degrees. How much is this angle? Can anyone guess? This is a right angle. That means it's going to be 90 degrees minus 1 degree is 89 degrees. Pretty straightforward, not too bad. We have, so those are complementary angles. Let's now talk about another big word. I'm just throwing these at you tonight. Supplementary angles. All right, supplementary angles. So now let's say we have a line like this and we have two angles. This one is going to be 80 degrees. This one is going to be 100 degrees because this means they add up to 180 degrees when they have when they're on a line, and then all the angles together will add up to 180 degrees. So let's try this one. This is a kind of complicated one. We're going to have a 90-degree angle here, and we're going to have a 40-degree angle here. Well, how can we figure out what angle X is? Question mark. Well, 180 is how much all of them are together, minus 40 degrees. So we have 140, 40 degrees left. Now we've got 90 degrees here. So we subtract 90 degrees and we get 0, 14, 5, So we get 50 degrees as the missing angle. So that's a supplementary angle. Now let's talk about angles in a angle. All right, so here's the thing. Triangles, no matter what kind of triangles they are, and we're going to talk about several kinds, will always equal 180 degrees. So we could have 45 degrees, 45 degrees, 45 degrees. That's not correct. They would all be 60 degrees. We have 60, 60, 60. Now that's very messy. Yikes. We could have a right triangle, the one I was kind of thinking of, which would be 90, 45, 45. We could have a triangle like this. I'm just making these numbers up, but it could have 20 degrees, 20 degrees, and then this is 140 degrees. This one, that angle is 140 degrees. So for a triangle, the angles are always going to add up to 180 degrees. No matter what, they're going to add up. Now for quadrilateral, and what does quadrilateral means? It means something with four sides. Quadrilateral. Four sides. And they have 360 degrees interior. So like here's a rectangle with four right angles. So you have 90, 90, 90, 90. So 90 times 4 is 360. So inside, so there are other kinds of quadrilaterals. You could have one that looks like this. You could have one that looks like this. But no matter how you do them, all the angles inside are going to add up to 180 degrees. Let's talk about types of triangles. Types of triangles. Well, what do we have here? We have three kinds of triangles. We have equilateral. We have isosceles. And we have scalene. Now for an equilateral triangle, all sides are the same length. For an isosceles, two sides are the same length. For scalene, no side is the same length. One way I used to remember them is equilateral is equal. Isosceles, 2i isosceles as two sides that are the same. And then scalene is scatterbrained. It's all over the place. I don't know if any of you ever had a friend who's like all over the place, that kind of thing. But that's scalene. Now I want to show one more thing with angles. This is a bit hard to get, but I think it's worth doing. When you have a line like this, so these are parallel lines. Parallel. And what does a parallel line mean? It just means they're always the same distance from each other. If you've ever been driving and you're with somebody on the highway, this is kind of the right example. It's not quite. And you're driving the same speed and they're right beside you, you'd be like driving in parallel. You're always like right there beside each other, the same distance from each other. If you have a line that intersects two parallel lines, things will be the same in terms of their angles. There are several clues we can get here. This is a straight line right here. So these two are supplementary. They're going to equal 180 degrees. Supplementary. The same thing with these. These are also supplementary. They'll also equal 180 degrees. The same thing with these. They'll also equal 180 degrees. So you see where this is going. They're like all equaling 180 degrees as long as you don't go around the line. That's very useful if you're trying to figure out how much one is and you don't have another. They're also going to be the same. So let me erase a bunch of the things I did. they're going to be the same as some other things. Oh, I did not want to do that. Fix that. Oh, I'm going to do a lot of fixing, it looks like. So parallel like this. So this angle is the same as this angle. Let's do this in color. This angle is the same as this angle. This angle, same as this angle. And finally, this angle is the same as this angle. Now I know you're going, Eli, that is like literally the coolest fact I've ever learned in my life. Like, thank you for blessing me with that. Like these lines are like these angles are the same. I don't know how I lived without that knowledge. I know you're thinking that, but you also might be thinking like, this is silly. That's probably more likely. Why is it important? It's important because it helps you troubleshoot and find missing angles. Like if you know this angle, then you can also know this angle because they're the same. I need to change my ink color to black. All right, so we're good now. That's just a little thing for you to think about. Now we're going to talk about perimeter. Perimeter. And perimeter is the distance around something. The distance around something. All right. So perimeter is the distance around something. We're going to let's do some. So classic one would be a farmer has a field and he wants to see how much fence he needs. So let's say the field is 40 on this side, 20 on this side, 40 here, 20 here. He's going to need to add all these up. So add all sides is how you solve for perimeter. So we've got to go 40 plus 40 plus 20. Well, not 22 plus 20 plus 20 plus 20. Then we got to add them up. So all those are zeros. We have 12 here and we added up 120. So 120 is the answer here. But we're going to have to be able to do this. So I'm going to give you an example problem. Now my farmer has this field. It's a hexagon. He's weird, a weird farmer to have a hexagon field. These are 5. And then these are, let's say 10 long. What is the perimeter of this? So solve this, put it in the private chat, put it, you can, put it in the private chat, put it in regular chat. What is the perimeter? And remember, you're going to solve for perimeter by adding up all the sides. That's just how you find perimeter. You add up all the sides. So what is the perimeter? Somebody put it in the chat for me, please. All right. Anything in the chat? I'll give it a few more seconds. Should I just work it? All right, I got one answer. And it is the correct answer. I'll wait and see if anyone else wants to answer it. All right. So to find the perimeter, we have to add up all the sides. So we have 5 plus 5 plus 10 plus 5 plus 5 plus 10. So 5 plus 5 is 10, plus 10 is 20, plus 5 is 25, plus 5 is 30, plus 10 is 40. So 40 is the answer for this weird farmer who wants a field shaped like a hexagon. All right, let's move on from this. Oh, we're going to do the concept of area. The concept of area. Now, what is area? Now, let's say our farmer's moved on from the field, from fencing the field, and instead of fencing the field, he wants to know how much. He wants to know how much he can surface he can cover. So instead of being concerned about the fence, let's draw him a fence. So that's a really ugly fence, but we drew him one. Now he's concerned about the grass. So he's concerned about the surface area of the field, how much it covers. Let's call area how much it covers. So how do you find this? Well, instead of adding the sides, you multiply. Well, it depends. Let's first do area of a rectangle. Area of a rectangle. What you need to do is multiply two sides. Multiply two sides. I'm sorry. We're doing a late one tonight. So we have the rectangle. So let's say we have this rectangle, and let's say it is 8 feet long here, and let's say it is 12 feet long here. Well, I don't know you, but I don't have my 12 times table memorized like I should. So I'm going to do this. It's 96. So the area equals 96 feet squared. Now here there's an important point. The important point is that when we write area, we have to do like feet squared, like inches squared, miles squared, meters squared. Whatever unit you're using to measure, we have to say squared and add a little exponent. So for a rectangle, we multiply the two sides. Now, why don't you all try and find the area of this rectangle? I've got a rectangle that is a square. Squares are rectangles, but rectangles are not necessarily squares. Let's now, why don't you tell me what the area is? So put it in a chat for me. I just want to see how you guys are getting it so far. All right. We got one answer in the chat. It's the right answer. To find this area, we have to say 4. 4 times 4 equals 16. Now let's do area of a triangle. Area of a triangle. Well, for this one, we need to be able to use a different formula. So for area of a triangle, the area A equals 1/2 times base times height. So what is a triangle's base? Well, think about it. Here's the base. And then from the base, we draw a line up here, and this is the height. And then we've got to multiply that by 1/2. So let's say we have this cute little triangle, and its base is 4 long, and then it has a height of 3. So you say the area equals 1/2 times the base of 4 times the height of 3. So we get, we can multiply 4 by 3 is 12. I would multiply that by 1/2. 1/2 times 12 is 6. All right. So that's area of a triangle. Now we're going to move into a weird world. We're going to move into circle world. All right. Circle world. And I'll put some circles on the end of my circle world thing. So when we have a circle, we're going to talk about several parts of this circle, although that is a bad circle. So there's the center. And this is stuff you need to memorize. The middle point. Then from the center, we can have a radius. The radius from center to edge. Then we can also have the diameter. Diameter. Edge to edge through the middle. So it's going from the edge to one edge to the other through the middle. Now 2 times the radius equals diameter. That's always going to be the case. And you're going to be able to use that to solve some problems. 2 times the radius is equal to the diameter. All right. So one more term, the circumference. Woo. Oh, sorry. All the way around the circle. I'm going to add this here. Circumference distance around circle. So in a way, the circumference is like the perimeter of the circle. You can kind of think of it the same way. Perimeter is the distance around like a rectangle or triangle. Circumference is the distance around a circle. So let's talk about some circle things. Finally, there's something called pi, a number. 3.14. So pi is a number that with how the universe is set up, it's just like something how the universe works. Pi is a very important number. It's about 3.14. It goes on forever, I believe. If you want to be a real nerd, there are competitions where you memorize digits of pi and then compete to see who, I guess, is the best nerd in that way. If you want to, whatever, but be my guest. But that's what pi is. We're just going to usually use the symbol for pi. We won't do anything else. Sometimes people say pi. Sometimes people use 22 divided by 7 for pi. So if you see that, that's what's happening. So let's talk about the area of a circle. So area of a circle is equal to pi r squared. So it's equal to pi r squared. So area equals pi, and then the radius squared. So the circle, the area of the circle is going to be pi times the radius squared. So let's say we have this circle. Let's say the radius is 3. What is the area? Well, the area is equal to pi times 3 squared. So the area equals 9 times pi, because 3 squared is 9. So that's like pretty simple. Let me do another circle problem. So now we know the diameter is 16 centimeters. Then we want to know the area. Well, area equals pi r squared. First, we got to find r. We know the diameter is always twice of r. So if we say 16 divided by 2, that's 8. So now we can say pi times 8 squared equals 64 pi. That's the area of that circle. Now let's talk about circumference, the formula, circumference. And the formula for circumference, and this is something you just need to memorize, C equals dP. Circumference, I hate writing this word, it's so long. Circumference equals diameter times pi. So circumference equals diameter times pi. Let's use a real circle. Not a real circle, like an example circle. Let's say we have this circle, center. Let's say the diameter is 4. So the circumference equals 4 times pi. That simple. Let's say we have another circle and we have a radius of 10. Well, now the circumference equals 2 times 10 times pi. Why 2 times 10? Because 10 is the radius, and the diameter is always twice the radius. So circumference equals 20 pi. That's pretty good, right? You guys are getting it. Let's talk about area again. Let's go back to area and talk about areas of 3D figures. So let's say we have a box that is a rectangular prism. So it looks kind of like this. I forgot to add this one. And you want to know the surface area of it. When you want to know the surface area of 3D figures, surface area of 3D figures, you need to find each side's surface area and then you add them up. All right, so let's say I have one that's like this. All right, so let's say it's 4 long at the ends. Let's say it's 5 high. 5, 5. And then let's say it's 9 long. So 9, 9, 9, 9. What is the surface area? Well, we're going to have to do each set of sides. So the first sides we have are on the end. Let me see if I have something to demonstrate. No, the first sides we have are on the ends, and they're 4 times 5. So 4 times 5 is 20, and we have 2 of those sides. Next sides we have are the like side sides, and those are 9 long and 5 high. So we can say 9 times 5 twice, 45, 45. Now finally, we can look at these top sides and the top and bottom. They're 4 by 9. So 9 times 4, 9 times 4 equals 36. That's 9, 36 equals 36. And now we need to add all of these up. That's going to be annoying. So these are 40. These are 90. These are 72, I believe. So now we can add them up more. We can say 90 plus 40 plus 72. We can say 9 plus 4 is 13, plus 7 is 20. Carry the 2. So 202 is our answer. I know that one was kind of complicated. Now let's talk about volume. So in general, to find volume, we find the surface area of the base, and then we multiply it. Multiply. All right, that's not writing well. By height. All right, let's turn that weird math language into real stuff. So let's say we have a rectangular prism and it looks like this. So here's the base. It's, oh, that was an interesting decision. Let me erase that. Oh, I erased everything. So let's say we have the base 4 times, I don't know, 6. And then we have this thing here that has height. And I drew it all different kinds of heights. Let's pretend these are each 10 high, even though they don't look like they would be. So we need to find the surface area of base first. Surface area of base. That's going to be 6 times 4. That's going to be 24. Then we have to look at what the height is. And then we multiply the surface area by the height. So 24 times 10 equals 240. And we're going to say these were feet, so they're feet cubed. So 240 feet cubed is the answer there. Now, what is volume? Volume is how much something will hold. Like we often measure volume in things like gallons or quarts or cups. It's a measure of how much it'll hold. And so if you think about it, it makes sense. You figure out how big it is on the bottom and then you multiply by how tall it is. That makes sense, being that's how you'd figure out volume. Let's do a slightly harder one. I'm going to type it in. What is the height of a rectangular box with volume of 140? Volume of 140, width of 7, and a length of 10. Well, we know that volume is equal to length times width times height. And we get that because these are the surface area of the base. Area of base. So we know the volume is 140. We know the length is 10. We know the width is 7. Then we have to multiply it by the height. So we can do some algebra. 140 equals 10 times 7 is 70 times h. Then we can divide both of them right then and there. And we have 140 divided by 70 is 2 equals h. So it appears this is 2. This box is too high. So it's a very shallow box. I've got not much more left for y'all tonight. Let me make sure I'm hitting it all real quick. We're going to hit some Pythagorean theorem. Actually, let's do volume of a cylinder. So let's now say we've got a water tower that for some reason looks like this. And it's got it's 100 feet high, and the radius of the base is 5. So we've got to find the area, and then we got to multiply that by the height. So we go pi r squared. Area equals pi times 5 squared. Area equals 25 pi. 25 pi. Now for the volume, we've got to multiply 25 pi times 100. And I realize I just made myself a big problem because this is going to be a big one. But the answer is going to be 2,500 pi. 2,500 pi feet cubed. And that's because we find the surface area of the circle, and then we multiply it by the height. Now let's look at, I want to give you some tips for circles. So circle tips. And I hope you'll go back and watch this video. I know I'm telling you a lot. So C equals dP equals circumference equals diameter times pi. The way I remember it is Coke equals Dr. Pepper. If you're from the South, like I am, where I grew up, the generic word you use for soda is Coke. You just call everything Coke. So if somebody says, I've got Dr. Pepper, you'd say, I got a Coke. So you can say Coke equals Dr. Pepper. It's the same thing. In the same way, you can remember C equals dP. Now, area equals pi r squared. What you can tell yourself is pi aren't squared. So pi aren't squared. They are round. So area equals pi r squared. Pi aren't squared, pi are round. That's just like a way to remember what they're trying to get for you. Now let's talk about something lovely called the Pythagorean theorem. Totally the most lovely thing you'll encounter probably as we're doing math here. Let's see if there's a problem here. All right, so sometimes we're going to get triangles, and they're going to be nice triangles. They're going to be very lawful triangles. They're going to have a right angle like this. It's going to have a right angle, and then so there are two other angles. This is called a right triangle. And when we have a right triangle, we can use the Pythagorean theorem. Lovely name, right? Pythagorean theorem. Awful math name. I'm sorry, I just ruined your night by using those math words, Pythagorean theorem. But when we have a triangle that uses the Pythagorean theorem, this awful term, we can find out how long the biggest side is from the two short sides, or we can find out how long the short side is from the biggest side and the small sides. I've already ruined your night by using these words, Pythagorean theorem. So I'm not going to use other words like hypotenuse and legs. We're going to use big side and small sides. So let's say we've got it. So the Pythagorean theorem looks like this. A squared plus B squared equals C squared. C squared is the longest side, and A and B are the short sides. So A squared plus B squared equals C squared. Let's put this into practice, although I'm sure you're like just so happy you're in a quick class and how amazing this is. So let's say we have a triangle that has sides that are 2 and 3 long, and we want to know the long side. So we can say 2 squared plus 3 squared equals C squared. Now, what is 2 squared is 4. What is 3 squared is 9. So 4 plus 9 equals is going to equal c squared. So 4 plus 9 equals 13 equals c squared. So to get the opposite of a square, we do something called a square root. So we can do c squared, we can do like that. And we're going to get the square root of 13 is equal to c. Now that was an ugly one because it ends in a square root. We can't get a clean answer. Let me give you a different one. Let's say we have a right triangle, which this, I'm just going to erase that. That's so bad. We have a right triangle. And it's going to have sides that look like this. One of them is going to be 4. One of them is going to be 3. Let's find the missing side. So 3 in theorem is a squared plus b squared equals c squared. So 4 squared plus 3 squared equals c squared. 4 squared is 16. 3 squared is 9. That equals 25. So 25 equals c squared. Now we can take the square root of each of these. We get 5 equals c. So 5 is the missing side. Let's do another one. Let's do like this. We have a right triangle. And it's going to have longer sides. Want to make sure I get some that are not going to be that is not going to be too ugly. Let's do sides that are 5, 12. So we got to figure this out. So a squared, or sorry, let's do, I just told you the answer, but let's do 13. So a squared plus b squared equals c squared. Well, now we don't have b squared, we just have a squared. So we have 5 squared plus b squared equals 13 squared. So now we can say 5 times 5 is 25. I don't know what 13 times 13 is, so let's do this real quick. 3 times 3 is 9, 3, 0, 13, 169. So 25 plus b squared equals 169. So now let's do some algebra. Minus 25, minus 25. B squared equals 144. Now, if you know your times tables, you know that 12 times 12 is 144. So if we take the square roots of both sides, we get b equals 12. So 12 is the missing side. So that's the geometry lesson. I know there's a ton there. Want to stop and see if anyone has any questions about anything, wants me to go back to anything. While you're thinking about it, I'm going to say I'm going to stop the recording here in a minute. I'll save this to YouTube. I'm going to go ahead and stop the recording because I think we're good.